6:48 now. I'm here with Matt, and Matt's also known as the Wise Guy. You can use your favorite CD for something other than blowing out your eardrums, turns out.
Yeah, apparently so. CDs are prisms, right, Matt?
CDs can be used sort of like a prism in that you can take white light and spread it into all the colors.
Okay.
And to understand this, first just think about throwing a pebble into a pond. You see a round wave that goes outward from where the pebble fell in. If you throw two pebbles into a pond, you get round waves coming from each of them, and if you watch carefully where those waves meet, you see funny interference patterns, because if the crest of a wave meets a valley of a wave, they cancel each other out, and you don't have anything.
So you'd see little flat areas.
Yeah, then you see little flat areas, and if two crests meet, then you get a bigger wave there. And so what you have to do is, if you think about having little ridges on a piece of material, like for example, this is a tiny piece of silicon that I have right here. It has little ridges about 25 microns apart, which is very close together. And if I shine a laser on this, then we're going to see some interesting spots appearing. And here's how I can explain that. Each of the little ridges on here, just think of as a place where you have a water wave or a light wave coming off. And if you have two ridges which are a little separated by some distance, like in this, if I just move these apart, you see that I get these sort of funny, I guess, some dark areas, and some light areas, and some dark areas. So what happens is when the light waves bounce off two separate ridges, and those two ridges are in two different places, then you get light areas and dark areas and light areas and dark areas. And if you were to stand over here and watch these light waves, you would see that as bright dots and dark dots and bright dots. And so what I'm going to do is I'll just do this with my green laser, because it's very bright. If you can hold this thing up, I'm just going to shine my laser beam on this thing that has these little stripes on it, and you see some dots on there. You see the light ones and the dark ones? Okay. Now, the interesting thing is it depends not only on the spacing here, it also depends on the wavelength of the light. So if I take a red laser, which has a longer wavelength, the spots are a little farther apart. So what happens is these grooves in this piece of silicon, or in other words, the grooves on the CD, they separate the light into these dots, basically, but they bend red light different than green light, different than yellow and blue and everything else, so it spreads it all out. So if I do this with a CD, you see dots that are quite a lot farther apart.
Much farther apart.
Isn't that pretty cool? And if I take my little red thing that I got for $5 at the gas station, I can do the same thing, and you see even farther apart dots. Okay? And that's why if you shine a nice white light at a CD, and you just look at it,
there you can see it.
You can see the colors. It's kind of hard to do on TV, but just stare at a CD yourself, and you'll see these beautiful rainbow kind of effects.
Yeah, you see you're seeing the different wavelengths from the colors?
That's right. So the reason you see all these nice colors is that the red light is bent differently than the green light, is bent differently than the blue light, basically by this. If this was just a perfect mirror, you would just see an image of the flashlight. That would be pretty boring. But since a CD has all these little grooves in it, which are separated by about 1.5 microns, and they go round and round and round and round, it's like a record used to be, except it's really shrunk, okay? And each of these little grooves acts as a source of light after the light bounces off it from the laser beam. And so they interfere, and you see these interesting colors. So
interesting. All right, next time around, what have we got?
Oh, we're going to show how you bend light using water and plastic, and we're going to show an optical fiber and some really neat stuff. You're going to like it.
Sounds good. All right, thanks, Matt. Well, we're headed to the beach. Sound like fun?
Oh, yeah.
Yes, you're supposed to say yes, that does. Yeah. That's still ahead in the wish.